decarbonizing commercial and industrial facilities, and to show you how to implement 5 key strategies to improve energy performance, reduce energy costs, hedge against volatile energy prices, and of course, to reduce your greenhouse gas emissions. So I hope we all understand the nexus between energy and carbon emissions. So if we are able to reduce our energy consumption, it goes a long way to also reduce our carbon emissions. What are the strategies I'll be talking about? So the first strategy that every organization or any individual or profession has to look at in decarbonizing their commercial or industrial facility is to understand and use energy KPIs. The second strategy is to implement energy management system. The next strategy is to optimize your building space and industrial process. The fourth strategy is to carry out energy audits and implement energy saving opportunities. Then the last strategy is to integrate renewable energy sources. The first strategy, understand and use energy KPIs. How do you measure progress towards your decarbonization strategic goals? Most organizations view decarbonization as installing solar systems, and others see it as replacing conventional ACs with energy efficient type. This invariably does not indicate success when there are no KPIs to evaluate performance of these solutions and also to improve. If you don't measure, you can't manage and improve. So it is very important that you establish energy KPIs and use them as part of decarbonizing your commercial and industrial facilities. So the energy KPI actually shows what the organization wants to do and how to measure their success. What are the benefits? It provides clarity and support, able to clearly define to follow along and support. The other benefit has to do with it provides signposts and triggers. So we are all monitoring. If things are getting bad, quickly we make sure we get things aligned so that we can remain focused on our strategic goal. Then the last benefit is it provides ways to communicate understanding of success. So if targets have been set to reduce energy consumption by 5%, if we are able to achieve, we can communicate that success. So it is very important that you establish this KPI and use them if you are considering decarbonizing your industrial or commercial facility. So first, have the KPI. What is the objective? You need to also look at how you can measure that and evaluate your performance. So I've put together 6 energy KPIs I have seen to be very relevant in terms of decarbonizing industrial and commercial facilities. So the first one is energy overhead in most organizations. So the cost is left in the hands of the accounting team or the finance team. Nobody knows the energy consumed for occupying an office space. So one of the KPIs that organizations need to have or know is the energy consumption and the cost. The next KPI is the energy use intensity. So when you have a commercial building, how much of your energy do you use per square meter? If you are an industrial organization, what is your energy use per ton of production. You need to have that as part of your strategy in decarbonizing your facility. Then your energy cost intensity. How much does it cost you in terms of energy per square meter of your office building? How much does it cost you in energy per your production ton? This is also very important that you know, so that you can effectively implement your decarbonization. Then the next one has to do with peak energy demand. So over the years, production for the buildings that you occupy, do you track the energy demand over the years? If you want to decarbonize, then it's important that you know, so that when you are set targets for reduction, you can be able to as well know the extent of reduction you are achieving. The next one is solar PV system performance. So it's not enough to just install solar on your roof or at your carport. It's not enough to do that. You need to monitor performance. So is it performing against the projected energy generation? If it is not, then it ought to be checked and improved. Then one of the most important of these KPIs is project economic analysis. So how do you evaluate your energy projects? Do you just look at the first-hand costs, or you just look at the cost over the life cycle of that energy efficiency strategy? So in the table, I've put together these KPIs under 4 categories. The first one is the macro category that has to do with the year-to-date measurement of your energy consumption, energy costs, also your specific energy consumption or your energy use intensities. Then the second category is the sub-metering level, where month on month you are monitoring or you are measuring your energy use intensities and your consumption, so that if you are able to set your targets, you'll be able to track and give your energy savings, and for that matter, your monitoring or KPI. So for compressed air systems in the industry, you need to be monitoring your energy use per specific CFM or airflow, for the system. When it comes to chillers or refrigeration units as well, you need to evaluate the energy use per ton so that you compare to benchmark values and improve. Then the last category, which is the economic component of your KPI, is how do you evaluate? Do you use simple payback to evaluate your energy projects? Do you use net present value? Do you use life cycle cost analysis? It is very important that this thing is considered anytime you are looking at decarbonization. If you take motors, for instance, over the life cycle of a motor, energy is about 50% of its O&M. So you wouldn't want to just buy a cheap motor, which will end up consuming more and you spending more. So it's very, very important that you evaluate the life cycle costs of these energy systems so that you can achieve your decarbonization targets. So the next strategy is energy management system. As I indicated in the previous slide, if you do not measure, you cannot manage and improve. Measurement is very key in energy management. However, energy management system is not about measuring at our facilities with energy management system. Metering is different from energy management system, though it's a component of energy management system. So why do you need to have this as a strategy in decarbonizing? It is proven that energy management system methodology is very proactive and effective in energy management. So it is very important that organizations that seek to decarbonize adapt this strategy so that they can be effective and be able to achieve their goals. So I've put in industry or in organization. So there's a scenario that has to do with the ad hoc energy management, and there's a one that has to do with the systematic energy management. So the systematic energy management is a strategy I want you to consider for your organization. So what happens in the ad hoc energy management? So in the ad hoc energy management, you don't really have management support. Somebody in the facilities management team or engineering team or energy team, has some knowledge about energy efficiency, and they decide to implement energy conservation measures. So when they implemented, they started seeing the savings, and you can see that waste cutting comes in. Then as soon as they start seeing the saving, everybody goes to sleep. In 3 months, 4 months later, energy consumption increases again. Then everybody rises again. Let's do something. Then we all rush to do something, and the consumption starts reducing. So this is a kind of ad hoc energy management, and this is the most commonest you can find in industry or in commercial facilities. This kind of ad hoc energy management does not help in decarbonization, because as you can see, when you reduce, you increase. So in effect, everything nullifies out, and you can't be said to be decarbonizing. So what I am proposing is the systematic energy management system. As you can see on the diagram, the one on the right-hand side, we have full senior management approval. They've committed to that. The organization has a policy. They have empowered the team, and they have also shared information across. So there is understanding throughout the organization of what to do. And for this kind of organization, when targets are set, because there is commitment and funding is made available, they are able to achieve more savings. So in year 1 to year 2, you can see that their energy consumption started dropping. Then from year 2 to year 3, it's dropped. Then year 4, it keeps dropping. So the beautiful thing about the energy management system is that it ensures continuous improvement. So every now and then you are improving and getting better. So how do you implement energy management system at your facility? This is an approach that is very common. It is called a plan, do, check approach. And this offers a systematic approach for integrating energy efficiency into your organization's management culture and also daily practice. So we have this plan, do, check approach to managing your energy. So the first one that has to do with planning, you want to first know management commitment. By developing policies, management comes in, they know their responsibility. You also plan your energy. What do? You need to know your baseline energy consumption. You need to identify the energy saving opportunities or the measures that you want to put in place. Then you go ahead with the next stage that has to do with the doing. The do is the action part. What I mean is that this is the part that is going to help you see results. So you need to provide training for key technical staff of your team, those who will be championing the implementation of the system. Then you also need to communicate. So in organization, you will want to use broadcasts to communicate to the staff, or you can also use direct mails as well. You also look at operational control. So what measures are you going to put in place to make sure that the target that you have set is going to work? Then for the procurement team, they need to be informed about what you want to do so that they don't just look at cost, but they evaluate energy projects using life cycle analysis. And of course, the other important energy management. The beautiful thing about this kind of energy management system is that you can integrate it with existing management standards like the ISO 90,001 and the ISO 14001. So the next strategy is optimize your building space. As you may be aware, pre-COVID era, we were all, fully going to our offices. Office attendance was 100%. But when COVID came, most of us had to work from home. I'm talking in terms of those who work in office buildings. And because most of us had to work on, some also were practicing hybrid working or flexible working. But after the COVID, just recently, we had an announcement that COVID is over. So it is expected that we go back to our full way of working. But what it is that most senior managers believe that staff or employees can continue with flexible working, and just to make sure that productivity is not affected. So according to McKinsey market review, it is observed that about 50% of employees want to work hybrid. So because 50% want to work hybrid, imagine that you went to new office facility, your employee were 100 and they were coming to work from Monday to Friday every week. And now you'll be seeing them coming to work for only 2 days within the week. It means that the facility that you have, rented out, is going to be wasted. It's going to be underutilized. And anytime it is underutilized, then there is likelihood that you are going to also waste energy. So it is very important that an organization considering the practice of hybrid working or remote working should consider optimizing their building space. So if you're able to optimize your building space by evaluating where staff can use and the areas that don't need to be used, you can find a way to close off those space so that energy system serving those space can be put off for you not to waste energy and also drive down your carbon footprint. So you look at your space and you evaluate the utilization. So the space utilization, the formula is the people count, the active occupancy, and the passive occupancy. So you do that evaluation, then based on that, you are able to establish the utilization and plan your optimization. So how do you optimize your facility? So in the photos in this slide, you can see we have an open space, the light is on, the ACs are on. The other photo has some number of people in the office, ACs are on, lights are fully on. Lights are on, ACs on, and they are not really serving purpose because the space is underutilized. So optimizing office space or building space is one of the good strategies you can consider if you want to decarbonize your commercial facility. So you need to carry out space functional analysis. How is the space ordered? How is it being used? You review your energy consumption over a period. How is the trend? Is it going up? Is it going down? You compare that to occupancy. Then you use technology or data to understand employee presence and behaviors. The other one has to do with you optimize your energy end use by downsizing equipment. So after you do your space functional analysis and you have the confirmation that certain spaces are underutilized, then what you need to do is you consider downsizing. So if you have plans to carry out life cycle replacement of your air conditioners, you don't do like for like replacement, but you rather reduce the capacity. So the same applies to your lighting. You also consider that, then you can consider using controls. So either using occupancy or presence sensors. You can also use VSD to control your energy use. So typically for commercial building, you have an air handling unit supporting about 5 floors or even 10 floors. And for these floors, because of the hybrid way of working, only 2 floors are occupied. However, the AHU is serving the entire 5 floors. So you need to optimize the energy system after you optimize your building space so that you can drive down your energy consumption and, for that matter, decarbonize. The next area in optimization is your industrial processes. In industry, according to lean manufacturing principles, there are 8 types of waste. But I don't want to speak about the other types. My focus is on overprocessing and overproduction because I've come to realize over many years of practice in the industry, carrying out energy audits, that anytime you are overprocessing and overproducing, it means that the other 6 type of waste is also, increasing. So if you are able to reduce or minimize the waste, by processing or by production, it means that the other kind of waste are also going to reduce. So if waste is eliminated in production and processing, energy consumption will be reduced and greenhouse gas emissions will also be lower. So how do you go about optimizing your industrial processes? So I've given a typical scenario. Let's say you want to produce, you are a manufacturing organization that produces pizza, right? So for the usual or the BAU kind of setup in most industries, you have the batch process. So you move from raw material, then you move to the next stage, then you move to the next stage. So you are moving from one batch to the other. So in this typical scenario, you have where spices or ingredients are added. Then after that, the whole set then moves to the next batch where it's probably baked and sliced. And it can be seen in the second diagram that most of you will be spending about 30 minutes to do this. However, if you consider the best way of process, which is called cellular manufacturing or continuous flow manufacturing, you see that you have the same kind of process in one location where immediately after you spread your dough and you start the process, you move to the next stage until you get to the end. So you don't go through the batch process with delays. And if you are able to eliminate the waste due to the batch process, it means that you are also going to reduce your energy consumption. So the strategy is you review the production process per product of your factory. You evaluate the time for processing a product from start to finish. You also identify the source of waste in the value stream of the process. Are there any bottlenecks? What are the interruptions? What are the delays? Then you eliminate or you minimize the waste. Some of the waste cannot be eliminated, but they can be minimized. If you're able to do that, then it means that your energy supply stream, so supply from, let's say, compressed air system, supply from your pump, supply from your boiler and steam system or hot water system, will also have to reduce because at the upstream, the process is optimized. So when you're able to do that, it means that your supply is also going to reduce and your carbon emissions or greenhouse gas emissions will also reduce. One of the most important strategies is to carry out an energy audit for your facility. You need to know your energy efficiency potential. Then you also implement your energy saving opportunities. So the energy audit is an important step for improving the energy efficiency and utilization in commercial and industrial facilities. And it is the key step for an effective energy management program. So you can't implement energy management system if you don't do an energy audit, because you need to know the baseline energy consumption and the opportunities for improvements. So the energy audit will identify, it will quantify, it will prioritize the wasted and lost energy and recommend actions to minimize or eliminate them. So you need to do the energy audit. It will help you to develop database, to help you to determine whether energy is being used efficiently. It will help you to identify cost savings and also identify opportunities for saving energy. So your energy input is equal to energy used plus energy wasted plus energy lost. So in energy audit, you want to identify your energy usefulness. You want to know where the wastages are and the losses. Then you put in place measures to eliminate or minimize your energy wasted and losses. So there are different kinds of energy audits. There are 3 kinds of energy audits, and there are different available standards that are used to carry out the energy audits. We have the ASHRAE standard, we have the British standard, we have the ISO and the European standard. For Ghana, the applicable standard is ISO. So we use the ISO 50002. So the type of audits that we have in ISO 50002 2014 is the 3 types. You have the type 1 energy audit, type 2 energy audit, and the type 3. So the type 1 energy audit is for smaller organizations like SMEs. Okay, you don't go and do any bigger thing. You need to know, you want to know your energy consumption. You want to establish your energy use intensity. You want to just identify the low-hanging fruits in energy saving opportunity implementation. So this is just a preliminary audit that you carry. And this kind of audit is an input to type 2 and type 3, where you do detailed energy audit. So for energy audit type 2, you are doing detailed energy audit for a site or a process. And this kind of audit is very cost effective for organizations with smaller energy budgets. So if your energy budget is not that big, then type 2 energy audit is preferred or recommended for you. The third type of energy audit is the comprehensive audit. So when you're looking at large facilities, okay, in the industry, in commercial buildings, very huge portfolio of commercial facilities, the kind of audit that you would want to do is a type 3 audit, so that you can get detailed understanding of how you use your energy and what needs to be done to reduce or improve on your energy performance. So this is applicable to organizations with high energy spend. So in the petrochemical industry, or in the steel and iron industry, or probably in the food and beverage industry, the agro industry, depending on where you find yourself, you would want to do a type 3 energy audit. You can also do type 3 energy audits for energy systems. So you can carry out an energy audit for a pump system. So let's say Ghana Water, for instance, you do a lot of pumping. You would want to assess your energy performance for these pump systems. So you do a type 3 energy audit. So for boiler or hot water systems or steam systems, you would want to do a type 3 energy audit for them. The same applies to compressed air systems or chillers or HVAC units. So these are very, very important. And this is key if you are looking to driving down your energy consumption, and for that matter, improving your energy performance and decarbonizing your facility. The last strategy is integrating renewable energy sources. Why is this the last strategy? The reason is that you have to first optimize your facility. You need to also improve your energy efficiency. Then you come here. The reason is that if you don't do that, it means that the renewable energy system that you are considering will have inherent inefficiencies. Okay. It also means that your capacity is going to be very high or very big, and your upfront cost is going to be very high. So it is very important that you first optimize your system, your facilities or processes. Then you also implement your energy efficiency measures after the energy audit. Then you can consider integrating renewable energy sources. So I've put together these two very important and common kind of renewable sources applicable to most industrial organizations and commercial facilities. So the first one is solar thermal systems. Solar thermal systems. They can provide about 50% of the heat demand in industrial processes and agricultural food production. As you may be aware, in industry, there are three kinds of heating requirements. So we have the kind that requires heating to temperatures below 80 degrees Celsius. We have the type of heating requirement with temperatures required between 80 to 250 degrees Celsius. And another type, or the last type, that has to do with heating with temperatures above 250 degrees Celsius. The good thing is that solar thermal systems can help do this work for you. And this will go a long way to helping you decarbonizing your facility. Solar thermal is also applicable in commercial facilities. So you can use it for your day-to-day warm water needs in hotels, restaurants, hospitals. It's also applicable for sterilizing, drying, pasteurizing, evaporation, distillation in industry. Advanced technology in solar thermal has proven that you can even get temperatures of about 3,000 degrees Celsius. So they can be very, very, very good in terms of driving down your carbon emissions or greenhouse gas emissions. So the second option in using the solar energy is the solar PV system. That is very common. Most often you can have the grid interactive type, which we normally call the grid tied system or the hybrid system. And this type is the most commonest you can have in commercial buildings. Then you can have the grid interactive with batteries for the entire load. Then you can also have the grid interactive with batteries for dedicated loads. So probably you wouldn't want to put your solar to power the entire load of your or some of the load of your facility, but you want to just focus on the lighting or your air conditioning or water pumping. So that can also be done. And you can also use your solar PV system as a UPS, where you are able to get uninterruptible power supply. How do you integrate solar energy into your industrial facilities or into your commercial buildings? Just remember that I said the two kinds that I have found very applicable and useful in industry or in commercial building is the solar thermal and the solar PV system. However, you don't just say you are going to install solar. A lot of consideration has to go in so that the right thing is done. There is a big problem with greenwashing, where a lot of organizations claim that they are sustainable just to woo clients, to patronize their products or services. But when you go into it, you see that no, things are so bad. And some of the reason is because of inadequate planning and strategy in deploying solar energy at your facilities. So the first thing to do is you need to evaluate your need of solar energy. Do you really need the solar energy? Do you have high thermal energy load or high electrical energy load? If you have high thermal energy load, then it will be more better for you to go for solar thermal system. If your energy load is very high on electrical, then it will be more beneficial for you to consider solar PV systems. The next one is, are there power quality concerns? Because inverters, by nature of how they are designed, because of DC and AC conversion, create a lot of harmonics. So you need to make sure that whatever solution that you are looking at would not affect your data center or compromise on the power quality requirements of your advanced manufacturing setup. The good thing is that most solar systems nowadays have very good, they are built so well that they are able to protect you from issues of power quality. Even if they will be there, capacitor filters, harmonic filters can be installed to ensure that the issue of harmonics are eliminated in your energy or electrical system. The other thing is you evaluate your peak load and your base load. So like the diagram I've shown, you can see this is a typical load profile of a commercial facility. All right. And you can see from the morning, this kind of facility, does a lot of almost it uses, it has a constant profile, so to speak. So they have solar installed, all right, but you can see that, and as you may know, solar peaks around 12 to 1 p.m. So the peak supply from the solar is around that time. Then after that, it drops. So all energy used before and after the solar supply will have to go to the grid. So you need to evaluate your base load. The base load for this profile is around 600 kilowatt hour. So you need to evaluate your base load. Then based on the base load, you can know the kind of solution that can help you to reduce your energy consumption, reduce your carbon emission, and be more sustainable. The next important step is there space for installation, and what is the environmental air quality? I remember a time ago, we had to do an assessment for a client, and apparently they wanted to do solar. They wanted to do solar. But what it is that Unfortunately, because of where the site is located, there is a lot of dust in the atmosphere. And it means that if you are to install solar on the roof, you are going to have dust covering the panel, and this will not serve purpose. So you need to really understand the environment you operate in so that you do the right thing. Unfortunately, some of the solar suppliers, probably for the sake of lack of professionalism or their interest of selling their solution to clients, they wouldn't mind. They will say, we can do it for you. They put the solar on your roof and you see that performance will not be as desired. So please, you need to know this as an owner of a commercial facility or an owner of an industry so that you can actually decarbonize as you want to. I hope by now you have really taken notes of these 5 strategies. As I bring my presentation to a close, I just want to recap on all that I have said. So first, you need to understand and use energy KPIs. The second thing is that implement energy management system, and that is the ISO 50001. You don't necessarily have to certify if your organization doesn't want to. The most important thing is you have it implemented and it is working. If you want to certify, then you can also, engage vendors who are into certification of facilities into ISO. Ghana Standard Board is yet to do ISO 50001 certificate. I believe when they are clear on that, most organizations in Ghana would want their facilities to be ISO 50001 certified. The third strategy is optimize your building, office space, and industrial processes. The fourth strategy, carry out energy audits and implement the energy saving opportunities. And the last one is integrate renewable energy sources. So thank you very much for your interest in this webinar and for your time. I will take questions. I believe there are a lot of them. If we are unable to exhaust your questions, my email address is there. You can send me direct mail and I'll answer your questions. You can also connect me via LinkedIn and I'll be more than happy to reach out to you. Thank you very much. And over to you, Kofi.
Thank you, Engineer Wiafe, for enlightening us with your expertise in these topics. I'm sure your presentation will provide us with actionable insights to drive our decarbonization efforts in our facilities. So it's time for the Q&A session. Please submit your questions through the Q&A feature, which will be the comments down there. We shall address them shortly. But I guess I would go first with my first question. So Engineer Wiafe, when you were talking about optimization of building spaces and envelopes, you mentioned that technologies can be used to understand employee preferences and behaviors. Can you please elaborate on that? Which kind of technologies could be used for that? Which kind of equipment are available to kind of get that?
Okay, all right. So let me start with the simplest. Every commercial facility have access control technology. So the access control, when you are accessing the building, you need to swipe your card. Then doors or turnstiles can be opened for you to access. So this data can be, used to evaluate the use of the space. So if you have about 100 staff, all right, and now due to the COVID and the practice of hybrid working or remote working, now you are getting only 20 of them coming to the office. You can use your data from the access control to know that indeed I have 100 staff, but only 20 comes to office every day, or 20 comes to office on this specific dates. So based on that, you will be able to carry out your space functional analysis and optimize the office space. There are other technologies, I wouldn't want to mention the names, but there are technologies that you can install at your premises that will be able to evaluate the use of the space and give you reports. so that based on that report, you can use that to optimize your building space.
Okay, thank you. Thank you for clarifying. Just a couple more from me. So among these 5 key topics that you've mentioned, which one would you say should be priority for commercial industrial facilities if they had to select one to start with?
In fact, I would want them to consider all of that, but one of the key ways of decarbonizing, considering the 5 strategies that I have outlined, is to consider energy management system. It's because you have full support from management. The organization has strategic goals on driving down their carbon emissions or greenhouse gas emissions. And you have collective understanding within the organization to achieve targets. So with this kind of management system, it helps to drive down your carbon emissions far better than probably just looking at just one of the strategies that I've mentioned. But of course, you can't have an effective energy management system without energy audits, because you need to establish energy baselines. So you can see that everything is interlinked. And if you want to do energy management system, you would also have to carry out building space function analysis. So you see that one way or the other, they are all interlinked, and it is best to consider all the 5 strategies.
Thank you, thank you. So it seems everything is interlinked. I think someone has just made a comment, Morrison Issa. He mentioned that in the presentation, you abundantly made it clear that there should be an assessment of the environmental air in order to eliminate dust from covering the OB panel, which in turn reduces the energy efficiency of the PV module. His take on this is that the evolution of technology has introduced dirt and dust sensors that automatically activate water sprinkling systems pre-installed with the system, but of course it comes at an additional cost to the client. Yes.
Yeah, of course, technology keeps evolving, but you see sometimes some of these technologies are, though they are there, but they are not common. All right, and the cost implication too doesn't make it interesting for building owners or even industrialists to go in for such kind of technology. So the best thing to do is to evaluate the environmental air quality, then you take the right decision.
Thank you for your comment on this. I think in relation to this right now, the solar space is a bit shaky, but then getting solar systems it's not too cheap right now. So I think what Ismaila is saying just falls in line with that. I think Shadrach has raised his hand. Shadrach, please, could you type your question in so that we'll read it out for Engineer Wiafe. Anyone else who has questions, please type it. Just to link with before the questions come in, if you want to learn more about the Energy Service Center, we have a website, www.agi-ESC.com. You can find out more things about us over there. You can find a schedule of events to see when we are having other webinars and other renewable energy and energy efficiency events. You can find out the services we offer. We have some publications over there in energy efficiency and renewable energy. So you can visit our website, www.agi-ESC.com. I think there's some other questions. Let me pick it up for Engineer Wiafe. Yes, I've seen a couple of people are still raising their hands. Kindly type your question so that we'll mention it to Engineer Wiafe. Otherwise, if we start the back and forth dialogue, it might take longer than the time that we have.
Just that sometimes it is easier to talk than the type.
Okay, Shadrach, since you're already on here, kindly ask your question so that engineer can see to you.
Okay, thank you very much. Yes. Thanks so much, engineer, for your nice presentation. The only thing I'd wanted you to do some detailed explanation for us is on the over-processing you suggested or you made a point on. Assuming someone is into a production of, let's say, tomatoes, and then the person sees that with my production process, I realize that I have a fixed charge, which is on energy. And my fixed charge is either I process or not, I'll have my air conditions, I'll have my whatever coming on. And so therefore, I have this amount I have to always pay. And then looking at the demand flow, it is better maybe I over process my products per day so that anytime my suppliers or my customers are in need, they can be able to come for the product and I'll make my money. In that situation, whilst I process and store, the storage alone, I will need energy to also take care of the storage. But in this situation, I have over-processed because the quantity I need per time for a specific customer is supposed to be less, but then I have to process more. If not, I cannot take care of my energy consumed. In this situation, does it still fall into the idea of over-processing as per what you made? Or it can just be recognized that it is normal because at the end of the day, I will make up the money to fill up the invested energy I did earlier. Thank you very much.
Okay, so thank you, Shadrach. I'll try to answer your question. I hope I understood it very well. So what it means for over processing, let's say you like your typical example, the tomato that you talked of. Let's say you want to produce tomato paste, okay? All right. Your consumers or your clients, they only need tomato paste, but you end up processing it to the extent that the quality required exceeds expectation. So your client is not going to pay you for that excess process, okay? And for you also using energy to over process, it means that you are going to spend more in terms of supplying energy and also paying ECG. So why would you want to do that? So in lean manufacturing, which is very applicable in an industry, you would want to do what we call the pool. So everything that you do should be based on requests from your consumers or what your consumer need. So if you're able to know what your consumer needs, you make sure that you produce according to their need. And if you are producing according to their need, you wouldn't be over processing. And like you said, if you are over processing and you are producing more, it means that you are going to stock more at your warehouse. And that also comes with cost because, like you said, you need to provide cooling for your produce. So if you are producing or you are overproducing and you are having to provide more cooling, then that means that you are increasing your greenhouse gas, footprint or carbon footprint, and it doesn't help your decarbonization strategy.
Thank you very much.
Thank you, Shadrach, for asking your question, and Engineer Wiafe for responding. We have another question from one of the listeners. And let me just use this to also announce. I think there was a bit of an error in the link. So everyone's name is coming as a Kofi Batini. So you could change your name to your appropriate name so that we can refer to you when we are asking the questions. So this listener said, great presentation. Apart from solar, are there any other renewable energy solutions we can consider?
Yeah, so I made mention of the solar thermal, which has to do with just providing heating for your process. So in industry where probably you need hot water for maybe helping in the drying of your raw material, or maybe for cleaning purposes, or sometimes you need hot water, okay, for sterilizing or for distillation or pasteurizing purposes. Then instead of using electricity, electrical way of producing the heat, or relying on, let's say, boilers that uses HFO or RFO, which produces a lot of emissions, you can consider the solar thermal. So this solar thermal becomes a good substitute, and it will help you to reduce your carbon footprint or your greenhouse gas emissions.
Thank you, thank you. Would you say eventually people can start looking at wind on a small scale for their industry?
So you see, the reason why I limited my strategy to solar, PV, and the thermal is because wind is not applicable just everywhere. It's not everywhere you can have wind, okay? But at least solar is very common. So why would you want to invest in wind when you know that it's not reliable or it can't be available? Okay, so it is better you focus on what you can really get and what you can, what can be reliable or available so that you can use for your facility. But if you happen to find yourself in an area where the wind is okay, like you are in Adafo or in the areas where wind levels or velocities are good, then you are better placed to consider wind as well as maybe solar for your decarbonization.
Okay. Thank you again, Engineer Wiafe. We've reached the end of our webinar. We are grateful that you've presented this for us and addressing our participants' questions. I'd also like to thank everyone else for joining today and showing your commitment to decarbonization. Remember, implementing these strategies will require collective efforts and shared commitment to sustainability. By optimizing building spaces and facility processes, conducting energy audits, adopting energy management systems, understanding energy KPIs, and integrating renewable energy sources, we can make substantial impacts on reducing carbon emissions. Please stay connected with us for future events and initiatives. Check our website, www.agi-ESC.com, for upcoming events, publications, green jobs, and to learn more about the Energy Service Center. Thank you all. Have a wonderful day.